works all on its own. It did. It's amazing. Everybody can see you now. Here's Fraser, guys. Hi, Fraser.
Hello, everybody.
That was that a hard video to make?
No. No. I mean, obviously you feel sad.
Right.
It was, I was, we were like, I was working on some stuff, and I think Carla was reading, my wife was reading some stuff about opportunity in the background, and I could hear her. She was like a little sad. She get a little sniffly.
Yeah.
Yeah. It's no. In terms of content, like it was how do I not just make this thing into a 2-hour long video? There's just so many amazing things. And as you look into each one of those individual events, it's really hard to just pare it down and just kind of give people the 13-minute gist of the mission and how they died. I mean, I could have done a 3 times long video.
Right. Yeah.
So no, it's but it is sad, but it's also, it went so much farther, right? Like
Right.
what else could you want? I mean, it was supposed to go for 90 days, and it went for 5,000.
Right.
Like,
exactly. It was great.
Each day after 90 was a gift.
Yeah, absolutely. Yeah. And also, like, even with Curiosity, so its wheels, Curiosity's wheels are pretty torn up, aren't they? I mean, these rovers only have so...
Yeah, they're not that bad. I mean, they understand what the problem is, and they're driving a lot more carefully now with Curiosity. So, no, it was, they were getting more wear and tear than they were expecting, but it's not going to be it's not going to have its wheels break on it long before the mission.
Right. I just remember seeing pictures of it and being like, yikes.
The wheels. No, it was just they were going across terrain that was really hard on the wheels, and they were driving in a way that was accelerating the wear down, and they've since learned their lesson.
Right.
So, yeah.
And someone says, have we gotten all the data on Ultima Thule yet?
No. We're still years away from that. I think the total download is going to take something like 20 months to get here.
Yeah.
And we're only 2 months into it. So we've only gotten a couple of pictures. So no, it's going to be this trickle that's just going to happen month after month after month, which I guess is good for the publicity of the mission. Mm-hmm. But yeah, no, it's going to go for a long time.
Yeah, it's really far away, guys. That's a lot of it, is that there's so much information to send back and forth. Same thing with the New Horizons.
Transmission that they can do is very small.
Right. Same with the New Horizons mission with Pluto. I mean, we had to wait for that too. We had to be patient.
and at that point, it was a lot closer. Like they only had to wait 16 months. I forget the total number, but yeah.
Yeah, it was substantially closer. So actually, that's a good question, Daddy Cupcake. What have we learned about the materials to use for wheels?
Well, I mean, they've definitely learned a bunch of the lessons for the Mars 2020 rover about what was wearing down the wheels on Curiosity. The wheels on Spirit and Opportunity was not that the wheel material was breaking down. It was with Spirit. It's that like the bearings seized, like the motor that ran its little wheel seized up.
Right.
So it had to drag the wheel behind it. And in fact, it couldn't even turn freely. It had to drag it, right? It was locked up and it was dragging it, which was terrible. But with Curiosity, like I said, the stuff that the wheels were made out of wore down faster than they were anticipating, and they've since changed the way they drive with Curiosity, and that's resolved the problem. The Mars 2020 rover has wheels that are similar to Curiosity, and I've seen some ideas for these really cool chainmail wheels, where they're sort of like they look like balloons made of metal. Mm-hmm. And that's not going to be in any of the current rovers, but it could be in future rovers. And then if you saw the I can't call it Rosalind Franklin rover. It has these tiny little wheels that are a lot closer to what the Spirit and Opportunity wheels looked like.
Mm-hmm.
And so we're going to see how that plan works out. The wheels seem smaller. Like it seems more likely that it could get stuck in something, in sand or something. So I hope it's no problem.
Yeah. I just showed people just some of the images of the wheels.
Yeah, yeah.
I mean, they're not super bad guys, but I mean, they were. I mean, this is going to happen though. They're rovers.
Yeah, yeah, yeah. They're roving. They're going over sharp volcanic rock. Like if you've ever been to Hawaii and you
Oh
walk
yeah.
around on the volcanic rock on
You
Hawaii,
usually
your
want to wear
shoes,
shoes.
yeah, your shoes get torn up
They can be. Yeah. Yep.
because it's just like you're walking around on sandpaper.
Right.
and
Yeah.
and so some of that terrain is brutal on
Yeah.
the wheels.
If I recall, those were cast metal wheels.
Which ones?
The Curiosities.
Yeah, I don't know what they exactly were. I remember there was like we were all freaking out about it for a while there.
Right.
Yeah.
And someone asked, Annoying asked, so what causes those dust storms? Well, the dust is actually dust, right? It's like talcum powder, like
Yeah.
dust. So it's not like a
They're aluminum.
sandstorm. It's not like what we deal with here on Earth.
Yeah, I mean, you get this situation where the dust is able to be put into the atmosphere, into the high atmosphere, and then the winds will carry it around. And because the gravity is so low and because the particles of dust are so small, they'll stick around in the atmosphere for a lot longer than they do on Earth. But you can get similar kinds of dust storms, but it won't feel like if you saw The Martian, and it looked like it was like a hurricane of dust. It won't be like that because in fact the air pressure on Mars is so low, so it's not like you'll take a lot of damage.
Right.
But what was the killer was just that it blocked out the sun. Opportunity was reporting that it was receiving, say, 99% less solar energy on
Yikes.
its panels, and so they just can't operate for very long. Curiosity didn't care. It's got a nuke on board. It doesn't mind, but Spirit and Opportunity, there was only so much they could do.
Yeah, Mythic asks, isn't Mars dust worse than moon dust?
No, it's better. It's bad, but the moon dust is really dangerous stuff because it's pounded up chunks of lava rock, almost like glass, like this silicate, and so if you look at it under a microscope, it's kind of like, I don't know, like really jagged pieces of glass. And if it gets into your lungs, the astronauts, when they went to the moon, they said the stuff got everywhere and they got into their lungs and they were coughing and they were, they had runny noses. It was like they had a cold. And it was just because this glass moon dust was getting into their respiratory system. The stuff and that's because there's no erosion on the moon to wear the stuff down. But on Mars, you've got wind that is blowing these particles of dust around, and so it smooths it out. And so if you look at the stuff on Mars, it would be more like little rounded pieces of rock than what you get on the moon.
Regolith asbestos, yeah. If you could choose a Mars spot to land, where would you pick? Well, I would go. I want to see Olympus Mons from like the base of it, even though trying to understand, like that's what is it, like twice the size of Everest?
Yeah, well, the problem with Olympus Mons is you could never grasp the size of Olympus Mons because the planet curves away from you. So if you stood at the base of the mountain, you couldn't see the peak of the mountain.
Right.
And if you were standing on the peak of the mountain, you couldn't see the base of the mountain because it curves away from you. So all you would do, no matter where you were, right? If you were standing at the base of the mountain, you would just see it sloping up.
Yeah.
And then it would become the new horizon. And as you climbed up, you would constantly see, until you got to a point that you actually could see the top of the mountain, but it would actually be surprisingly close.
Right.
And same thing. But I would love to stand in the crater at the top of Olympus Mons and see just the size of the crater all around me. I would love to go to the Valles Marineris, which is the deepest chasm in the entire solar system, stand on one side and see the other side, stand at the top and look down the cliff to the bottom, stand at the bottom and look up, be at the bottom of this. Yeah, that would be just a stunning place to be.
Yeah, and even though Mars is, we talk about all the things that are wrong with Mars, it puts a lot of what we have here on Earth to shame, like,
Yeah.
Mount Everest or the Grand Canyon, just what you were saying there. Like, these are things that we think are really cool here, and they are cool,
Mhm.
but on Mars, totally
Well,
different.
we have no idea. I mean, we have oceans here that cover up whatever 70% of the
Right.
land on Earth, but on Mars it's all bare. So you get a chance to see all the really cool features. Who knows what awesome features are hidden down at the bottom of all of these oceans, right?
Right.
Marinette, was it the Marianas Trench? I
Yeah.
think like that.
Yep. But yeah, I think landing at the base of Olympus Mons, even though you can't see it, because I knew obviously that would be the case, but still, just knowing that that's kind of insane and crazy in and of
Yeah.
itself. Just knowing that something of that magnitude is right in front of you. But yeah, going in that crater would be really really cool. Um, Someone was asking about something else. I don't know what it was, but there's the Hayabusa stuff today. Aren't they doing the rock collection
Yeah.
today?
Yeah. So the Hayabusa is happening tonight. I think it starts around 8 o'clock Eastern time. I forget the exact time, but yeah. So the Hayabusa 2 mission is going to finally be attempting to collect its sample. So
Hmm.
it's been orbiting around the asteroid Ryugu for about 6 months now. It's thrown all kinds of landers and hoppers and stuff at the surface of the asteroid, and now it's going to try and grab its return samples. So the plan is spacecraft is going to and they're going to live stream the whole thing, which is great. It's about 19 minutes delayed, but the spacecraft is going to lower its orbit. It's going to get to the surface of the asteroid, and then it's going to shoot an impactor, like a bullet, into the surface of the asteroid. And now the thinking is that before they thought the asteroid was an asteroid, big rock,
Right.
but now it really looks like it's probably going to look more like a chunk of, like a collection of gravel.
Hmm.
If you got really close, it would just look like gravel. And so the JAXA engineers simulated what this looks like, just like a pile of rocks, and then they shot their impactor into it, and you got this little puff of dust came out.
Isn't
And
it like a
that's
bullet that they're going to shoot into it?
Yeah, they're going to shoot a
Yeah.
bullet, but like the thing's going to come right down to the surface of the asteroid, and then it's going to shoot a bullet into this gravel that makes up the surface of the asteroid. It's going to kick up some dust and debris. It's going to sniff that up, right?
Hmm.
I sort of imagine like some kind of, I don't know, it's just going to, like a nose, right? It's going to like get a good snoutful, and then it's going to back away, and then it's going to bring that sample back to Earth. And hopefully they're going to get more than they did with the previous Hayabusa, because the last Hayabusa mission in the end was successful, but it brought back micrograms of asteroid material. So it just wasn't a lot.
Hmm.
And so now we've got, this time the Hayabusa 2, that, everything has just been going just great.
Yeah.
Yeah, is by far one of my favorite missions that are going on right now, because it's just like its budget was low. They were willing to test a lot of really interesting new technologies. It's got, they used an ion engine to sort of keep their launch mass down. And then they incorporated their own rover, a German and French rover or hopper, and now they're going to do a sample return. So it's just the whole package, and
Yeah.
I'm really excited about that.
Um,
And then the other thing that's happening tonight at roughly the same time
uh-huh.
is a Falcon 9 rocket is going to take off tonight from Florida. It's a thrice used rocket, which
Uh-huh.
is amazing. It's going to
Yes.
be carrying a telecommunications satellite, as well as a lunar lander for Israel, the Space IL. But it's
Oh.
actually not for Israel. It's a private group out of Israel. And they were competing to win the Google Lunar X Prize, the $30 million prize, to be the first group to land on the moon and move across the surface of the moon. And the competition just stretched out for a really long time. And eventually Google decided, okay, that's it. We can't keep this prize going. But the folks at Space IL said, we're going to do it anyway. And they have continued along, and they're about to do it. So hopefully tonight we will see this rocket take off. The main payload is the communication satellite, but the secondary payload is this little lander that's going to go. It's going to take 40 days to get to the moon, and then it's going to land, and then it's going to hop, and it will win the non-existent Google Lunar X Prize.
Well, aren't they doing something else? Forgive me for mixing up all these names. I feel like SpaceX has been all over the place. The Dragon, so SpaceX will launch its first Crew Dragon.
Yeah,
soon.
The Crew Dragon is essentially the replacement for getting humans, for NASA to be able to get humans up to the International Space Station. So the space shuttle wrapped up in 2011, and since then, for the last 8 years, NASA has relied on the Soviets, or the Russians, and their Soyuz spacecraft to ferry humans to and from the International Space Station over the last couple of years. And they were relying on the Russians for their Progress cargo vessels. And in the last couple of years, they shifted over to using SpaceX with their Dragon capsules to actually send cargo up and return it back from the station, as well as Progress.
Right.
And so, but NASA put out a contract to get its own method of getting humans up to the International Space Station. And so they put out 2 contracts, one to SpaceX and one to Boeing. The one to SpaceX, they're going to be doing the Crew Dragon. So essentially it's a crewed version, CREWED version of their capsule. And then for Boeing, they're doing what's called the CST 100 Starliner, and it's the Boeing version of a crewed capsule. And so both of these, they've already chosen the people who are going to fly first on it. The first test launches should be happening in the next couple of months. Definitely by the summer, both will have had a chance to test. And then hopefully by the end of the summer, we should start to see the first humans go to space on board these crewed vehicles. So American built, American astronauts going to the International Space Station and not relying on the Russian hardware anymore. So I think that's great. I mean, I think that the US should absolutely have the ability to send humans to space again. It's kind of weird that they don't.
Maybe so. That's funny. So maybe sometimes when in the future, when people actually do land on the moon again, they can take pictures of the Apollo landings. I wonder if anybody would.
Well, I mean, pictures of the Apollo landings have already been taken.
Right. Again.
By the Lunar Reconnaissance Orbiter, which is currently flying around the moon right now. And it's taken tons of really interesting. You can see their footsteps as they move around. You can see where the flags are. You can see all the hardware. You can see the lunar rovers, all that stuff, right? And in fact, the Lunar Reconnaissance Orbiter took pictures of the Chinese rover and lander. Now, I think 3 times they've released pictures from NASA of this. Of the lander and rover, which is really cool. So sure, by all means, next time someone goes to the moon and gets closer, they can take more pictures of the various Apollo landing sites. But yeah, you can see all the Apollo landing sites from orbit if you want. If you just type into Google Apollo landing sites orbit,
and then it'll bring up all the green screens.
yeah, and then feel free to fall into a conspiracy coma.
Right.
Where everything is part of the conspiracy.
Whatever happened to, and also Star Map, I will ask that question, but just to keep on a little bit more on track here. Whatever happened to the Dragon 2 capsule in flight abort test when they said they were going to detonate the Falcon rocket mid-flight?
Oh, I don't know. I didn't hear that was going to happen. That's crazy.
Yeah. Okay, Star Map. It's an off topic from Mars. It's fine, totally fine. We were just starting with that just because, the video and everything. But
and a lot of really interesting things have happened. And opportunity died in June 2018. It's old news.
Right.
Sad news.
Sad.
Because NASA gave up trying to communicate with it, but it is old news.
Yeah. Does it change?
We know that Neptune has a new moon.
Right. A new icy potato moon.
Yeah.
I'm so excited. Yeah, I had someone tweet that to me last night when I was, insomnia. I always check the space stuff late at night. Someone tweeted it. So that's actually really, really cool. And it looks like the Voyager missed it, just barely, right?
Don't you have some streaming content that you watch that puts you to sleep? Like, 'cause that's what people always tell me. They're like, "Oh, Fraser, I just want to let you know that I just fall asleep to your videos." I'm like,
To
"That's great."
Astronomy Cast, everybody
Yeah,
says that.
yeah. I get it. I do the same just to other, YouTubers, video game streamers, and I just fall asleep.
Yeah. Yeah. No, I do. But I haven't been doing that lately. I should probably go back to that because that was not a bad way of dealing with the insomnia stuff.
It's probably not right. Like what I want to do, what I wish I did was I would read a book every night. And I got to a point where I was feeling really good about myself. I'm like, oh yeah, I just got the new copy of Space 2.0. I'd love to read this book. You're welcome, Rod Pyle. I just promoted it here on the Skylias channel. I would love to, I've got they pile up, right?
Yeah.
I've got a million books and I would love to read them, and it does make me sleepy, but I would rather watch someone play a video game better.
Yeah. No, that's what I usually do. And that usually works. So maybe that's what I've done wrong is I started reading like space articles way late at night and then I keep thinking about it.
Yeah, no, I can't do that.
So I'm probably doing it to myself, but
this isn't your insomnia. This is your curiosity.
Right. It doesn't help. It doesn't help at all. But Star Map says something scientifically that it figures that our galaxy is warped in a twisted shape.
Mm-hmm.
Yeah, the Milky Way is not just this flat, nice disk. It's actually got these curves and.
How's your space engine doing? Has it got that updated yet?
No,
we're
in it right now. That's the nice, pretty background with the large Magellanic Cloud. But nope. That'd be really hard to. I mean, because they do such a great job at the like the molecular dust clouds in here and everything. It'd be pretty hard to show, I would imagine.
Well, I don't know what the level of the warping that they've calculated that it is, but I'm sure at some point they'll update it to give a more appropriate warp to it.
Yeah.
I don't know.
Because it is. I mean, I don't know the like you're saying the degrees of if it's pretty slight and minuscule.
I don't have that number in my head, but in theory they could, future versions as we learn more about this, right? As we learn more about what the galaxy really looks like, you can imagine things like Gaia are going to do this really careful analysis of what the shape of the Milky Way is, and we'll get a real sense. I mean, we didn't even know whether it was a regular spiral, a barred spiral, whether the galaxy had 2 arms, 3 arms, 4 arms. We're still figuring out because it's hard, right?
Yeah.
You're on the inside.
You can't get a bird's eye view.
Yeah, right.
Good luck.
What is the outside? Imagine if you try to figure out what the outside of your house looked like by looking at the reflections of cars as they drive by.
Right.
It'd be hard.
It's really tough. And so all we really can do is look at other galaxies that seem similar.
Well, and so you see all these examples, right? We can see thousands of examples of galaxies, and they're all mostly different. And then you can try to figure out what are some structures that they have in common. And then you look at from within our galaxy and try to map out those structures and then try to pattern match that against the other galaxies that are out there.
Yeah. Star Map asks, I mean, do we have to look up differently, or is that just no, you don't have to look. Nothing changes from our vantage point here, knowing that the galaxy is warped.
Yeah.
But you know what I did learn? So I was talking to OPT last night because I was telling them that we want to do more of these star parties, and the weather is just going to be terrible for the next week.
Oh, is
just
it?
terrible.
Well, and then I'm going to Costa Rica with Paul.
Right.
And then I'm back like around the 11th, I think, of March.
Which,
by the way, I won't be here. I'll be here next week, but I won't be here the week after that. So
right.
Put that in your calendar.
Okay, I'll keep that stored.
But also, Paul won't either.
So. Right. So so I guess the weather, even in the California and in the Texas, both are just terrible. So really bad right now. So that's why we haven't done that.
Yeah, welcome. And the moon, the stupid moon last night.
Right.
The super moon, super stupid moon.
Super stupid snow moon.
Super stupid snow moon. Yeah. Was terrible.
Right. And so that's another deterrent. We tried, guys. Remember, we tried. Fraser gave a concerted effort. And the moon's really just annoying. Like, we just can't do it when it's around a full moon. But in the future, definitely.
Well, we will be able to once I learn how to use the narrowband filters that come with the Texas observatory. They don't have any on the Although I'm sure they will eventually install them. They don't have anything on the California Observatory, but the narrowband filters will let you see even when there's a lot of light pollution or in like when it's a full moon.
Right. Ricky says you need more telescopes over the world. Oh, that's the
Yeah.
plan. That's
That
the
is
plan.
the plan. I know
That's
Dustin wants to put a telescope in every house
yeah, and even in space.
and even in space.
So so even outside of the world,
Yeah.
you know, that's
Just give it time. There'll be
yeah.
telescopes.
It will happen. He is very ambitious, and that whole company is just driven to bring space to people. So it's going to happen. James Webb hype. That's not what we're talking about at all. But,
But yes,
but
like
yes,
we'll get hyped about James Webb at the drop of a hat.
yeah, yeah.
We have to live to the year 3000.
3020.
Yeah.
I'm just tacking on 20 years, but
We're just gonna add 20 years every week
yes,
to the launch date.
yes, absolutely. And you know, there was a tweet that I retweeted from Universe Today last night that was amazing, talking about how far Earth's atmosphere extends, and it extends past the moon.
Yeah.
I thought that was amazing because, again, Universe Today, guys, he is the
There you
publisher
go.
of it. Amazing space news. Go on about
that's
that.
cool. The exosphere, I forget the name of it. I forget the name of the atmosphere that's and obviously there's not much, right?
Right.
Like very, very little atmosphere out there, but still the Earth's atmosphere extends out a significant amount around the Earth.
Yeah. And I tweeted that out, guys. I do retweet a lot of Universe Today or Fraser stuff.
Thank you.
Because, well, it's great. Like, it's, you know, there's a lot of people out there that try to do space news and you know, things even just like, I'm sorry to say this, but things like space.com. I definitely, and it's not just because Fraser's here, I would choose Fraser's stuff over any of this any day. It's a great resource. Space.com is great. It's nice.
Good.
It's a nice backup, but you have a lot of stuff, you know.
They just have more resources, right? So they are able to hire more writers to work on more stuff, and they have a really good domain name. So I'm not gonna, you know, and there's some really good. I mean, it's a lot of times it's the individual names of the people. Like Mike Wall is one of the writers there, and he's really good.
Yeah.
Oh man, I forget some of the other names. Even Paul sometimes writes for them.
Yeah,
So
Paul does.
A lot of the times I think you want to get to know who your favorite journalists are and then follow their work around the internet, because a lot of the times they work on different websites. Ian O'Neill used to be the head of Discovery Channel Space on their website. He's really good. Amy Shearer Title from Vintage Space used to work with Discovery. I really like Dave Mosher's work. He's at Business Insider and sometimes Popular Mechanics. So, and I think Eric Berger at Ars Technica is like the best space news reporter. So I think that it's not necessarily about the publication. It's about the capabilities of the individual writer. Elizabeth Howell works for space.com, used to write for Universe Today. What you're seeing with Universe Today is you're seeing my sensibility. You know, I'm choosing the stories. So all the stories that or 99% of the stories that we report on Universe Today are there because I said, I'd like this story, please, and assigned it to a writer. So that's the only difference. I think I probably have a more hands-on approach with the writers, because there's really there's two parts to this job. There is all of there's sort of the river, the torrent of news that's flowing by and making decisions about what is interesting and newsworthy and isn't conspiracy and isn't overly hyped and not clickbait and is useful and is going to be interesting for people. And for writers, they will just get bogged down if they have to spend the time trying to weed through all of that information. And so I like to just, I like to be that choke point. I will look through all of the sources. I'll find the stories that I think are going to be appropriate, and then I'll divvy them out to the various writers so that they can focus on writing and not actually have to spend a lot of time trying to pick the stories that they're going to be reporting on. And I think a lot of the science writers out there, they're overwhelmed.
Oh yeah.
If you were to ask, I'd say if you were to ask every single science writer out there and say, are you overwhelmed? Their answer would be, and how? Because you have all of the, now it's just turned into inside baseball, I know, but you have all of the news that you have to sort through and figure out what you're going to report on. Then you have the work of actually doing the reporting, and then you have all of the follow-on discussions and communications and promotion and feedback and just managing the conversations with all the people that are interacting with the news that you're writing. And that takes away from the actual writing and reporting. And it's tough, right? Like if you go onto my YouTube channel, I'm in there in the comments all the time, and I throw hours every day at that work because I think it's important.
Yeah.
And I think and I think people enjoy being able to have that conversation with me.
Oh yeah. Oh, I agree. I agree.
And but yet if I just spend all my time just having those conversations, then I'm not making videos.
Right.
And so
you have to divvy up your time.
And if I'm not spending time looking for stories, then I won't know what to be able to make videos on.
Right.
So all of those pieces have to come together. And so that's why I think that's the role that I play with the team for Universe Today is I'm already panning for gold all the time, so I can save them that part of the puzzle. And in fact, I allow them to interact with their audiences if they want, but I definitely don't demand it in a way that a lot of I think of other publications do.
Right.
Because a lot of publications they've just added, oh, and your other job is to get out there and interact with your audience all the time, in addition to all the writing that you're supposed to be doing.
Right.
And that's tough. And it really, especially when it's people are negative.
Yes.
It can really wear down your just your psyche.
Yep.
And I'm sure you experience it. Like, your chat is great, right? But I'm sure there are times when you end up on the front page, etc., that you just get this venom and toxicity that you just want to.
Yeah, no, at least a few times a day, even sans the front page, a few times a day. But that's just kind of the nature of it.
It is the nature of the beast. Yeah, no, for sure. But it's kind of like if you brought on, I don't know, if you expanded the family and you had a couple of people that were streaming on this channel with you, you are now toughened to that toxicity and you've figured out a way to live with it.
Oh yeah.
And I'm sure if you had some other woman join you, you would try to protect them a bit from that.
Yeah, I mean, as best as I can. Sometimes things slip through. And there's.
Yeah. By the way, while you do this, people are going to make inappropriate comments about you for an hour. And
it's usually what I have to. Yeah, I usually give them I forewarn them that there's going to be people that are going to say stuff that and just to ignore it because that's
which is sad, but that is just the reality of what it's like right now. So. Brand Scott says the blow is softened by casual drinking. And I think it's great. It's like you, Tazara, saying that we don't put up with the BS here, and I think that's exactly right. That you build up a community that helps you be the immune system to that kind of toxicity, and that really helps a long way.
Yeah,
and I think that I don't think people who are commenting, who are being that force for good, really appreciate how much of a service they're doing to set the tone, to call people out when they're being assholes, and to keep everything on and try and minimize the amount of of soul wearying comments that you have to listen to.
We're pretty lucky. Like, we don't, I mean, compared to other places, this is like nothing. So,
yeah, and I get the same thing. Like, people are always amazed at how delightful the comment section on my channel is.
Yeah,
and that comes from, I hope, me setting the tone and being there in the trenches,
that the
rest of my team doesn't have to experience it.
Yeah, no, a lot of people with just all of this, the whole like tone, I guess. Some people come in and be like, is this community is this has to be fake. you know.
Yeah. What, people saying nice things and
People
politely
being
disagreeing with each other?
wonderful.
What the?
Wow. I know.
Yeah. Have you ever had this where you see like a discussion? Like I get this on my YouTube channel sometimes where you'll see like someone makes a comment and then there's 15 comments below that.
Mm.
And you kind of go, oh, and you just like, your first glance, you're like, oh, what, I'm gonna have to start, removing people and throwing them out, and I'm just gonna have to dismantle this hornet's nest of nastiness. And then you look at it and you're like, oh, that person said something. That person said something nice.
Yeah, they took
had
care
a
of it.
disagreement, but then they worked it out and they had a nice conversation and they're friends.
Yeah.
You're like,
Yeah.
what?
Yeah.
Is that even possible anymore? So
yeah, exactly. No, it's something in here, and there's like a term in Twitch. I don't know if you've heard of the White Knight thing. Have you heard of White Knights?
No.
So it's basically just people that will stand up, for whoever it is that's streaming. There's more of a link to it, I guess, with lady streamers, but but like when that happens in like guys chats, they don't really say it too much. So it's it's kind of weird, but I don't feel like that's really a thing. Like if I just see all people as the same. So I guess if anybody's standing up for a streamer who's being just kind of attacked on some level, if anybody stands up, like I don't know. It's weird. Isn't white knight a negative term? It is. Yeah. No, they've made it a negative term.
Oh, really? So it's like some kind of
like you don't want people that stand up for you.
Right. But is it like mansplaining? Is it like, you know what I mean? Like is it a certain point that it's like it's crossed some line where it's a creepy thing, it's a bad thing?
It can be. It definitely can be creepy, but I don't have really any of that in my chat. People know the boundaries. But I do have a lot of older people that I'm even young enough to be their daughter, so they might look at me as like a daughter figure. Yeah. And so they can be protective of me in that realm. And so like just people don't understand there could be several different layers of that,
Right.
So, but yeah, no, it's definitely had this like negative thing, and it's very interesting in internet culture, like and seeing it on Twitch. It's one of those really, really interesting things.
Yeah, it is interesting to see these communities form and these new social interactions get worked out and feel old. Just feel like I don't get it.
Now everybody's relating. Yeah. So yeah, Daddy Cupcake, he has a daughter around my age, so and maybe a younger sister. Geez, I'm sorry. But it's true. So it's and those people usually, I mean, we don't really deal with a lot like again, like and you've had some wise advice there where I've just kind of nixed it more and more, dealing with just people coming in and just kind of wanting to just be not great, not conducive to any kind of chat that I would want. So I
feel bad for the trolls.
Yeah.
The well-meaning trolls on my channel, because they're gone.
Right.
Like they wanted to make a hilarious troll joke.
Right.
Nope. Sorry. Not interested.
No. So let's see. I think there was a few other questions.
There you go. You've been friend zoned.
Great. That's another thing that's been negatively termed, which is weird, but I sent you an awesome 50 black hole animation in the middle of the star cluster on Instagram.
Me or you?
Me. So
okay.
An awesome 50 black hole animation in the middle of a star cluster. Oh.
Did you hear that they're trying to figure out a way that they can use colliding neutron stars
for new particles
detected through gravitational waves as a standard candle for determining the expansion rate of the universe?
Oh, right. Mm-hmm.
Yeah,
and with more of these kind of detections, that will really help over the next.
That when you get two neutron stars colliding together, they're colliding with a very specific amount of mass that you can then detect using gravitational waves with a tremendous amount of accuracy. And it might very well be that in the next decade or so, as LIGO and the next things after LIGO will happen, you're going to have, you have the visual standard candles, you have type 1a supernovae and maybe quasars now and other things, mirror variable stars, but you will also potentially have you'll be able to see them in gravitational waves and have this completely different method, which
Yeah.
is really exciting.
And that's with, guys, that's what I've been talking about with the LEGO. So the advanced LEGO Plus. So LEGO's shut down. They're going to turn it on in 2024, or that's what they're saying at least. And that they could do these detections, every day is what they were saying that I was reading.
These collisions are happening across the universe all the time. It's just a matter of us getting a better detector to be able to see them happening.
Yeah. And then being able, like what you were just saying there, to being able to measure the expansion.
Yeah. And Bill Nash is asking, do gravitational waves redshift? Yeah, they do. Right. As the gravitational wave collision is happening in some far off galaxy, you can measure, this is how the standard candle works, is that you measure the strength of the gravitational waves, you measure the frequency of the waves as they're passing, and then you're able to use that to calculate their distance and how fast they are being carried away. And the big question that astronomers, the big dilemma is this question of how fast the universe is expanding.
Right.
They have two measurements of how fast the universe is expanding. One based on how quickly galaxies are speeding away from us, and one based on the expansion rate that's baked into the cosmic microwave background. Both are very accurate and have error bars that are relatively small, and they are two different numbers, and they don't overlap. So in other words, they're certain about one and they're certain about the other, and they don't agree.
Right.
Which is a really troubling answer. And one of the questions is whether the expansion rate, you saw the Big Rip one, I think last week, this, if the expansion rate is changing, is increasing, then it might lead to the universe tearing itself apart at an atomic level 80 billion years from now.
Right. Wow, good questions coming through. Really, really good ones. I know we can compare gravitational waves to sound waves. Can they resonate? Can they interfere?
I forget. I mean, again, I'm a journalist, not a physicist. So I believe that, well, it's not that they resonate, but I believe they can interfere.
Yeah. That's what I'm going with too, but I'm not 100% sure.
Yeah.
How can you measure the expansion rate when it's constantly increasing?
Well, that's the key, is that you measure the increasing expansion rate, right? That's the challenge. And so
Right.
the way you even describe the expansion rate of the universe, the Hubble constant, is that, and I forget the number, like 75
The Hubble constant, that's not a constant.
kilometers per second per megaparsec or something like that. I forget what the exact definition of it is, but essentially for every new megaparsec that appears in the universe, then the rate that things are expanding increases by 75 kilometers per second. And so the more universe you get, right. So if you measure, say you have a square that is a megaparsec across, and it gets 1 second later, you've added 75 kilometers. Then you add another one, and it just keeps increasing.
Well, there was actually a really, really good question. Shiza said, why are neutron stars more useful than black hole collisions?
Well, the trick with a black hole is you can have a black hole that has 1 million times the mass of the Milky Way. You can have a black hole with 1 billion times the mass of the Milky Way. So the neutron stars they're sort of this in between. If you have a small star that dies like the sun, then you get a white dwarf. If you have a star with, say, 8 times the mass of the sun to maybe 15 times the mass of the sun, when it explodes, you end up with a neutron star as the remnant. And so it will end up with a couple of times the mass of the sun as its mass, while black holes can be all kinds of sizes. So black holes are everything that's more, but neutron stars are right in the middle. And you can tell as they're spiraling into each other, they're moving at this very specific velocity as they come together. And you can measure the frequency as they come together. The big black holes are actually very difficult for us to be able to for us to be able to detect because they come together so slowly.
Yeah. Some of chat's confusing. Yeah, because the neutron star merger, we actually detected too. We actually saw it too. That was a cool thing about that. Sorry, I'm trying to see if there's other. I saw you doing this because we watched one of yours with Dr. Paul, and you had to scan questions too.
Yes.
I was like, ha ha ha. Fraser
Ha,
has
ha,
to
how
do
you
it
like
too.
it now?
Yeah.
Yeah.
By
I
observing
can just
distinctly.
grab questions right from the chat if you want, but
Yeah, no, you definitely can. You definitely can. This is not a thing that
but no, this is your show, not mine.
I'm not a
I'm
moderator.
I can let you set the tone and the kinds of conversations you want to have happen here.
Oh yeah, we did watch with Dr. Wright too. That was actually really good, even though we did meme a bit because he's so animated. He was so animated.
I know. Yeah.
Oh gosh, it was amazing though. It was absolutely great.
Like,
well, Lottie,
stay this right distance from the camera, please.
Oh yeah, no, he kept getting closer. Everybody's like, he's gonna eat the camera.
But and actually this week we had a great chat with Kimberly Cartier, who's one of our co-hosts on the weekly Space Hangout, and she was terrific. It's great to, because normally we're always just going so fast and it's just this back and forth about the actual story that we're talking about, but it was great to sort of hear her story and talk about her journey from being a scientist to being a science journalist.
Yeah. Wait, let's see. So someone said, by observing distant galaxies, we can see supernovae behavior turning during different age of the universe. Yes.
Yeah.
Mm-hmm.
Yeah. As we look out into space, we're looking back in time.
Yep.
Which is the great gift of astronomy. Archaeologists wish they could do that.
I know. To be honest, I have a problem with the whole theory that the fact they're looking so far out means that they're going back in time. That means nothing for today's universe.
Yes, I mean, for sure. You look at the moon, you're seeing the moon as it looked a second ago. When you look at the sun, you're seeing the sun 8 minutes ago. When you look at Andromeda, you're seeing it 2.5 million years ago. But we can see this progression, and things that are 2 million years ago or even 1 billion years ago don't look that different than how they look today. It's only when you look at stuff that are 10 billion years old, 12 billion years old, that things start going way back. Different.
Yeah. Because that when you look at like some of those Hubble deep field or the extreme deep field, that's when you start to see things that probably don't look like that anymore.
Right. Yeah. I mean, they will have collided and they will have merged with other galaxies and they will have turned into giant elliptical galaxies. I mean, the ones that you see that are rapidly going through star formation, chances are that star formation is over.
Right. Just like with our own galaxy, we were much more active a while ago. We still have some, and we still have a good amount, but
I mean, we could have a quasar again in the future.
Yeah, we could. And we've been talking a lot about that, about active galactic nuclei and stuff like that.
Yeah.
So can we know the age of a black hole?
Can we know the age of a black hole? No.
We can know mass.
I can't think of a way that you can know the age of a black hole.
Maybe if it is one of those, the ones that are in the center of the galaxy. So if they're active, they would be an active galactic nuclei. If they're not,
but you don't
dormant,
know when it formed. I mean, it really looks like those supermassive black holes that are at the hearts of Milky Ways. They formed in lockstep with the galaxies.
Right.
As the galaxies came together, the overdensity in the middle turned into the supermassive black holes, and they formed bit by bit. And as the galaxy built up, the black hole got bigger as well. So, and if you have, I don't know, if you have two black holes that merge together, what is the age of those that both formed at the beginning of the universe? What is the age of that black hole? Is it the age that those two merged together? Is it the age of the separate parts that formed at the beginning of the universe?
Yeah, still old AF.
Yeah, super old. Yeah.
Yeah.
It's only when you have a thing that starts to age as it's born, like say all of the stars in a globular star cluster. You can see that all of the young stars are long dead, that all of the middle-aged stars are long dead. It's only the stars that last a lot longer are still alive.
Mm-hmm.
And so you can tell how old the cluster is by the oldest stars that are left.
Yep. They're like the retirement homes sometimes.
Yeah.
Yeah. They just
Yeah.
they that's where stars go to retire, above or below a galaxy.
Yeah.
um is the Big Bang caused by universal expansion? The universal expansion dark energy?
Well, no. So the expansion of the universe is the leftover momentum from the Big Bang.
Right.
So at some point, the Big Bang caused the universe to expand.
Yeah.
And Big Bang is a really bad thing because it makes in your mind, it makes you think of an explosion, right? And so the analogy that I always try to give people is imagine the universe as this grid, a three-dimensional grid that goes on forever, maybe, right?
Mm-hmm.
And that at one point a long time ago, the grid, the squares in the grid, the cubes in the grid were very close together, very small, maybe the size of an atom, smaller. And then for some reason, everything got farther apart. Everything grew less dense. And so the spaces between the grid became larger. The universe became less dense. Now, it might have been that the universe was infinite. So this grid, the spaces in this grid were only an atom size across. And now the spaces in this grid are, millions of light years across. Yeah. And yet it went on forever. So it was infinite in the beginning and it's still infinite now. It's just more infinite. And then the other possibility is that it had some finite side, but it wrapped like a 3D game of asteroids. And so you go up the top of asteroids, you appear on the bottom, you go to the right of the asteroids, you come out on the left-hand side, you go right, you go forwards, you come out of the back, right? And so that's what it could look like if it was finite. And so something, and if you can figure out what that something is, then you get to have a Nobel Prize.
Right.
Something caused this expansion of the universe, of this grid. And that initial thing, the universe has been coasting ever since. From whatever caused that force in the beginning, everything has been coasting since then, except we now have this addition of dark energy, which is this accelerating force that's appearing. The more space you get, the faster things are spreading apart. And that's like this addition. And and they got that Nobel Prize for finding this addition.
Yep. How do stars form when matter is accelerated? So when matter is in accelerated expansion. So usually star formation comes from, that gas is a collisional material. So you can have galaxies when they merge. It creates a lot of new star formation.
Local
things like that.
gravity that is stronger than the expansion that's happening.
Right.
And so you have these overdense regions where the gravity is the thing that was stronger. Even though space was spreading apart, there was still more gravity. It was of a region that was pulling it together. And now what you're getting over time is you're really just getting this separation. You've got lots of regions that have nothing in it, and then lots of regions that have a lot of stuff in it. And over time, you're going to get more and more of that. These gaps, these voids in between the galaxies are going to grow larger.
Yeah.
But the galaxies, if they have gravity to pull towards each other, they're going to do that. And so like right now we have the Milky Way and Andromeda and M33 and all the other galaxies in the local group. In the future, they're all going to just mush together into one big star pile.
Yep.
And then there's going to be huge gaps between that star pile and the next star pile where they could merge together over time.
Yeah. And you're also referring to how gravity handles that gas and dust and how it just starts whipping it around too, with the material that's there. But yeah, there are voids in these gaps where there's not material to work with, and then you wouldn't get star formation in those areas.
Yeah. And so the star formation is just wherever you get the overdensities, where you get the matter, then the material comes together and it forms into stars. But people always ask, why isn't the Earth increasing in size? Why isn't the Milky Way increasing in size? But as long as the gravity of the Earth can hold itself together, it's way stronger than this expansive force that's going on in the universe.
Oh yeah.
Right.
Oh yeah.
And so then it's like if you're standing in a river say two people are standing in the river and they're holding hands, right? And yet things are floating down the river. You're like, why doesn't my friend float down the river? Well, because you're holding onto their hand, stronger than the force that is floating things down the river. Now, if you let go of your friend, they will start to float down the river. Gravity is friends holding hands in a river.
Yeah, and Jupiter and the sun won't let go of Earth, guys.
Right. Yeah.
I mean, that's a different.
Going to let go of us. Right. Sun's got us.
The sun's got your back, guys.
Yeah.
In the end, is it possible that only one huge black hole will remain?
In each place that is where the density happens.
Right.
So, yeah, I mean, sort of. You can imagine that the future universe is going to be black holes where all of the densities happened. Stuff that just is orbiting too far away and won't end up in a black hole. And then space in between those regions of black holes. And that's it.
Yeah, I think it'd be good to get... So Katie Mack's working on her book still. I think it's going to come out next year. She has some pretty cool ideas about how the universe will end. In fact, that's mostly what she's been taking up the last few years here.
Yeah, I mean, it's always those same ideas that it's like the heat death or the big crunch or the big rip.
Big rip.
Yeah.
The deep
freeze. And so now that, the video that we did last week was about how, and in fact, it looks like the big rip might be the way.
Yeah. Yeah. To be honest, I love the fact that we don't know.
Yeah.
Yeah.
Let's find out.
Yeah. The fun is in the fact that we don't know. That's the whole part about astronomy, is a lot of this stuff is just constantly changing. And it's so cool to be in a state of really not knowing what the hell's going on. I mean, that's what it comes down to. Let's see. So I'm never going to give you up, Jupiter. Yeah. I'm seeing if there's more questions. I'm not seeing.
Jupiter mostly wants to throw us out of the solar system.
Yeah. Jupiter's in a tug of war a bit. But it's
yeah. And Jupiter is not our friend. Like people, I know Rand Scott is saying that Jupiter is a goalie, keeping objects from reaching their Earth goal. No, it's both.
Yeah, it's a love-hate relationship.
Yeah, it throws as many things our way.
It's like the bully you want to be a friend, but you know.
Exactly. I guess.
Yeah, that's how I would see it.
Will punch you. Yeah.
Yeah.
So Jupiter is throwing stuff at us and also absorbing stuff from us. So, it's both. It could very well be that Jupiter was responsible for bombardments in the past.
Yeah, I thought
it jiggled up the gravity, jiggled up the asteroid belt.
Thoughts on the newly discovered discrepancies in physics and sound? Well, Najee, that might be a good one for for Dr. Paul. For Fraser and I, talking about. Yeah, that would be great for Paul. Yeah, that would be a great one. We did read, I think it was the other day, Phil Plate's article on Oumuamua, where they think that it might be a fluffy asteroid or comet or.
We reported on the possibility that it's a torn up comet, which was another piece of research that came out.
Yeah.
So
fractally made, maybe though, just like in protoplanetary disks.
Yeah. I glanced at it. I haven't actually read that story and I haven't seen the
pretty
paper,
cool.
So
yeah, I can send you. Well, I mean, you can look up Phil's article. It was on his Twitter not too long ago. I think a few days back, but
yeah.
But are we holding hands in the river with Jupiter?
Right.
To a degree, right? To a degree. I mean, Jupiter does contribute
we're holding hands with the sun in the river, and Jupiter every now and then comes over and gives us a push. And we hope we can keep holding on.
Fraser really doesn't like Jupiter.
Jupiter. There is a chance that Jupiter will throw any one of the planets out of the solar system at any time. Through its gravitational interaction. You want to make the solar system work better, remove Jupiter.
Oh man.
I know.
Oh man.
Yeah. Jupiter, anything, right? People always say like, oh, would the solar system be in balance if you remove Jupiter? And like, and how, right? The most balanced, perfect system that you can have is one star and one planet. There's no gravitational interactions with that. You add one more planet, now you got gravitational interactions. You add 8 planets, mayhem. So we have no idea the kinds of shenanigans that have happened over the history of the solar system. Mercury is weird because it's just like a metal ball.
Yeah.
Did it get smashed early on its history by another planet and have all of its outer layers removed? It looks like the Martian moons were caused by an impact. Our moon came from an impact. Uranus is on its side.
Right.
Where
Venus
did the
is
asteroid
rotating
belt go,
slowly
Jupiter?
backwards.
Where did it go?
Right.
So I think that we can feel pretty confident that gravitational interactions have just caused all kinds of mayhem over the history of the solar system.
Yeah. We have a weird solar system, guys. It's pretty cool, though.
Yeah. I mean, we know that like Uranus and Neptune switched places, and Uranus was knocked over on its side, and Jupiter moved inward, and so did Saturn, and Jupiter has been keeping the asteroid belt all tumbled up. So yeah, if you want to make, people always say like, oh, if we build a Dyson swarm and we dismantle the planets, are we going to cause any problems? No way.
You don't think if we nixed Jupiter that our orbit would be a little disturbed?
Be better.
You think it'd be better?
Yeah, we would be much more stable without gravity. Everything that you remove, you get rid of the gravitational interaction.
Oh.
Yeah. Chef MDT second disagrees with me that Jupiter protects too many things.
Type in this chat.
Yeah. Jupiter does both. Jupiter absorbs asteroids and comets and also deflects their orbits to throw them towards the Earth. And astronomers just like write papers about both of these things happening. So, yeah.
Takeaway from today, blame Jupiter.
Yeah. No, we can just dismantle Jupiter, turn it into our Dyson sphere. It'd be just fine.
Yeah. Well, I think that's
Saturn.
about
like,
it.
If we had to pick one, right? Like we love Saturn's rings.
Yeah, but they're not going to be there that long.
I know.
So,
That's true.
I would say Mars. We can get rid of Mars.
When they finally fall into Saturn, then we'll dismantle Saturn.
Yeah, let's get rid of Mars.
Yeah. Yeah, what Mars got going for it.
Yeah, let's just use Mars for resources.
Oh man.
All right. Well, thank you so much for
No problem. But before we go, I think it's important to know that your sub goal is only 4 out of 15. And when you think about the work that you do every week here on Twitch in what is like just a wasteland of ASMR and Apex. What's the game? Apex. What's the new game?
It's Apex, but it seems a little bit more likable than
Apex something or other. Someone's going to tell me that now is the time to subscribe. There's 222 people. How many of you are actually subscribed? ASMR Pex.
ASMR Pex.
Apex Predator. How many of you are subscribed to Skylias and could support the work that she's doing? If you can subscribe to her channel, then she can keep showing up here every week, bringing on guests and helping make the science happen. So I think we all appreciate the work that she does. And if we can have more of the kind of material that we want, we make the world that we want. And the way you do that is to subscribe. No one's listening now.
No one's listening.
I think I'm out. I've tried to help you bring on more subscribers.
I know they're tough. They're tough. Sometimes, I mean,
what is it going to take? I guess is the next question. Does she need to bring on more experts? Does she need do we need to see more ASMR channels? What's it going to take?
Popo, thank you. I'm helping. Yeah. No, it's Star Map. And I get people that have names like Star Map, and I'm just like, wow, your Twitch name is Star Map.
Good name. Yeah. Snacks. Promise the snacks. All right. Well, there you go then.
Yeah. ASMR space stream. Never going to happen, guys. Never.
Yeah.
Well, thank you so much.
No problem. Super fun. What are we going to work on next week? I think we're going to do we're going to do a video on flying the friendly skies on Mars, all the cool flying spacecraft that have been thought of. Oh, no. We're going to talk about why it's so hard to land spacecraft on Mars. So that's going to be the topic.
Because that's actually pretty cool.
The atmosphere is rough. So
Yes.
that'll probably be next week. So stay tuned.
Well, hey, someone just subbed.
There we go. You did it. We did it. We got 5. We'll call it there.
Awesome. Well, thank you again
All right.
so much.
Thanks, everyone.
All
and
right.
we'll see you all next week.
Sounds good. Bye.
Bye.